All right, so now we are looking at instantaneous rate of change. I want to make sure you understand. Remember when we said average rate of change, we're saying from 5 seconds to 10 seconds, what is their average speed? Now, when I say instantaneous rate of change, we're saying what is the speed they're moving at right now, at this instant. You can no longer use change in y over change in x. Because if I'm doing it right now, that means there's no change in x. So that means our denominator would be 0. Okay, let's put average rate of change just to remain. Remember, average rate of change, we said average rate of change. If we had two quantities, let's say we are coming from A going to B, we were saying that our average rate of change would be FB minus FA, F of A, over B minus A, right? And we say this came from us knowing that it was the change in Y. So maybe let me do it like that. Let me take this down. I'm going to do this. Highlight this part. Let me highlight this part. Wrong. I'm going to highlight this part. Yes. Okay, like this. The highlighter is normally giving me problems when the laptop gets hot. So yes, something like this. I want this part. Yeah. I'm going to move it down. And then I can erase this line. Put it like this. This came from saying change in Y over change. There has to be some change in X. Now we are saying, what if your X is not changing? You want at one instance, you can't use this formula. Average is for an interval where things were changing. So your change in X would be B minus A, right? If you can't use it for an instant because the denominator would be 0, if there is no change in X, that means you say something over 0 and that is undefined. So we can't use this formula, okay? Average rate, let's say, what if it was not from A to B? You know, one thing I want you to know is saying FB minus FA over B minus A is the same as saying it is the very same thing as saying FA minus FB, right? O over A minus B. If you start with F of A here, then make sure you're going to say A there, okay? And then if you say minus B, you make sure you do a minus B at the bottom. If you start with B, make sure you start with B also at the bottom. Then your answers will be correct. These two things will give you the same answer. Now, when we say instantaneous, we could also have, let's say it was not from A to B. Let's say it was from X to A, okay? We could have written it to say average rate of change is FA minus F of X over A minus X. Or we could have said it is F of X minus F of A. Remember the outputs over the inputs, which is X minus A, right? These are the things. Now, we are going to be using this one, the average rate. Let's say we had it from X, so we'd say average. We're still doing average. I'm just putting one more thing. We're saying average rate of change. Average rate of change. Okay, average rate of change between A and X, right? Between A and X. This was just going to be equal to F of X minus F of A over X minus A. Never forget that. Now, when we say we want the instantaneous, we want what is happening right now. This comes from the definition of limits. If we want the instantaneous rate of change, we are going to reduce instantaneous rate of change. Come on, right, please. Instantaneous rate of change. What we are going to do, I know it's giving problems, you forgive me, okay? When you see do that as the laptop heating. It's instantaneous rate of change. What we're going to do is, we are saying we are going to start reducing the time interval, this X minus A. Let's say from X to A was 10 seconds, right? One was 15 and one was 5. Now we'll reduce. One would be, say, we reduce from, let's say it's now 10 and 8. So there's now 2 seconds between. We reduce again. Let's say it's now 9 and 8.5. We keep reducing the difference in time until we get, so that is what we'll be saying a limit. And as we are reducing, we would be seeing what is happening to our answer. What value is it going towards? And that is the idea of limits. We would then guess to say, when we are at just 9, that means the value would have been this one, because from 9 to 8.5 was this, and from 9 to 8.9 was this. Our values were going towards this answer. So that's the idea of limit. So we're saying all we are going to do now for us to get instantaneous, it would now be the limit. The limit, okay? The limit, the guess as x approaches a. The guess that we get by analyzing what is happening as we are going towards, as we are reducing, right? We're looking at what's going, that's the limit. So it is f of x minus f of a, the same formula over x minus a, but we are going to reduce until we see what is happening. So it is the limit as x approaches a. So I want you to see the limit as x approaches a is f of x minus f of a over x minus a. This one we sometimes call it the first derivative of a. So we put a dash, forward lining dash. That is for instantaneous rate of change. You want to see it applied in a question? Let's go and apply it in a question. And here we'll be finding instantaneous velocity. What is instantaneous, class? Instantaneous means at that particular time, not average. You're going between two intervals. No, between an interval like between 5 and 10 seconds. No. At exactly 5 seconds, what are you moving at? Like our speedometer does, using limits. That's why limits are effective. If an object is dropped from a height of 1,000 meters, wow, its distance above the ground in meters after t seconds is given by this function. So we have a function that is giving us distance as you fall. Find the object's instantaneous velocity. Once they say velocity, we know that they want h forward slinging of t, which means the instantaneous rate of change. That is what they want. We have been given h t. Now they find the instantaneous velocity, h forward leaning of t after 4 seconds. It means the instantaneous rate of change after 4 seconds. So that means when my t is 4, so it will be h dash of 4 instead of t, because I now know that t is 4. And this would be, okay, let me first put for you h dash of t, right? If I want to get this one, remember from our formula where we said, okay, let's say we had f dash of a. This was equal to f of x minus f of a. It's the limit. Forgot to say. It is the limit as x. This one is a recap. It is the limit as x approaches a of f of x minus f of a. Remember, you start with f of x. It is x approaching a. You start with x, f of x minus f of a over x minus a. Okay, what matters, what starts doesn't really matter, but we want to use this same convention all the time. Okay, so now let's do the same thing here. What are we going to say? We are saying our limit, we want now h dash of 4, because we are saying, they say the rate of change when t is 4 seconds, after 4 seconds, at exactly 4 seconds, this would be equal to the limit as time approaches 4 of what? Of h of t is the same as f of x, because our original function was h of t minus h of 4. Okay, x is approaching a. It's f of x minus f of a over t minus a. So what is this going to be equal to? What is our h of t? It is 1000 minus 5t squared. So it is limit as t approaches 4 of 1000 minus 5t squared. This is the first. This is the h of t. And what are we subtracting from there? We are subtracting h of 4. Okay, h of 4 means wherever there is t, we are putting f4. So it will be now 1000. We are subtracting 1000, right? Let's do it. We are subtracting 1000 minus 5 by 4 squared. Okay, and this is going to be over, it's 1000 minus 5t squared, and we are putting 4, right? H of 4, wherever there is t, we put a 4, over t minus 4. This is not t minus a, but it's t minus 4. Okay, because it's time approaching 4. So it will be over t minus 4. T minus 4 doesn't change at the bottom. So it's going to be still the limit as t approaches 4 of what? 1000 minus 5t squared is going to be just 1000 minus 5t squared. Let's see what's going to happen on this other side. Minus here, what do we have? 1000 minus 5 by 4 squared. So if I put this in the calculator, I'm going to say 4 squared, I'm going to get my 16 times 5 is going to be 80, of course. Then if I say 1000 minus 80, right, I must get what? 920. So I'm going to say minus 920. So I don't need a bracket since it's one thing, so it's going to be minus 920 over, and this is all over t minus 4. And then what do I get if I say 1000 minus 920? Again, I'm just going to get 80. So it's the limit as t approaches 4 of 1000, this 1000 minus this 920. So it's 1000 minus 920. You get 80 minus 5t squared. Okay, so it's going to be 80 minus 5t squared over t minus 4. Is that okay? And when we now have something like that, now what are we going to do here? Well, when I see it like this, then what we're just going to do is I'm going to try and factor out 5 on the top. So it's going to be, look at what happens. It's going to be limit as t approaches 4 of, if I factor out 5 on the top, is going to be 5 comes out. I will remain with 16 minus t squared over t minus 4. Okay, because now I'm going to try, but I can't put 4 yet, because if I put 4 in here, if I substitute 4, my denominator will go to 0. Remember, now when you're doing limits, we have arrived at the point of limits. So if I try 4, I try 4 in the denominator, that's where it matters. I see my denominator goes to 0, so I can't use it. So I'm going to try and factorize. Okay, that is why I tried to put 5 out, and I see, okay, after putting 5 out, I have limit as, that is where my thinking is coming from. I've explained to you, right? Is now limit as this of what? 16 minus t squared is difference of 2 squares. 16, square root of 16 is 4, square root of t squared is t. So I can say this is going to be 5. Then I have 4 plus minus t. Okay, sometimes we normally like to write with 4 minus t multiplying 4 plus t, like that, and it's over t minus 4. Now, do I have a t minus 4 at the top? No, but I have a 4 minus t. I can change it to t minus 4 by multiplying by minus 1. So that means I'm going to take out minus 1 there. It's going to now be the limit as t approaches 4. Since they are all multiplying, I can just put a minus 1 outside. It will be minus 5 now. Then here it will be t minus 4. And here it will be now 4 plus t. It only changes here. It will change here only because they are multiplying, so you don't have to affect everybody. And it's t minus 4 outside. So now t minus 4 is going to cancel out with this t minus 4. And I'll be able to get the limit as t approaches 4 of negative 5 multiplying 4 plus t. Once it's like this, I use the method of substitution because it's a polynomial, and my answer would be, so it will be equal to minus 5 multiplying 4 plus negative 4. Okay, I've put my t as t approaches 4. Oh, it's t approaching 4. So it's going to be, this is not a negative 4, it will be 4 plus 4 rather. So it will be minus 5 multiplying 4 plus 4 is 8. And I'm going to get negative 40. And what is it? Instantaneous velocity, so it is meters per second. And you are done. So you get the limit and you use the techniques of limits that we have been learning. Once I see my denominator cannot get a 4, I have to factorize. So I'll try to find ways to factorize. That's what I did. And once you do, you substitute. When you have a polynomial, you get your answer, and that is it. You are done. Okay? Goodbye for now. See you in the next video.